All right. So yeah, like in the next couple of minutes, I want to show you like an easy way how to inspect any sort of like LCMS data or GCMS data in the web browser. So no need for installation of complicated things. But yeah, to give you a little background first on how we came up with like the GNPS dashboard, and this was mainly work done by Ming Wang, who's kind of like the brain behind the software here. Yeah, like there was a kind of like a long ongoing discussion of wanting a tool to visualize this data quickly right out of GNPS network jobs. And yeah, to give you a little bit personal background, so where I'm coming from. So yeah, I come very much from the instrument side. So I'm a wet lab chemist, analytical chemist. I work with mass spec since a long time, and yeah, like I love spending time in the lab working on the machine, and I don't know, taking out quadrupoles and so on. Then here, this is Ricardo, who's actually a bioinformatician, but Ricardo, the same way as we also, of course, need to spend time like preparing the samples that then go into the mass spec. And then last but not least, both of us also like spend some time on the computer, and I guess you may have realized that you may need to spend a lot of time on the computer too. And if we put numbers on that, I think that's kind of like my work day, right? Like I work a little bit on the mass spec, now even less than as a postdoc, but yeah, it was always like a small percentage. Then sampling and sample prep, that takes some time, but it's also very little in comparison to like the computer work we all do. And I think this will be probably for many people in omics just like that, or even move more towards the computer side. So now in that framework, and I think that's hopefully also the conclusion for like this week, right? We have a patchwork of different software tools that we kind of like put together either in I don't know, like a kind of semi-continuous way by going step through step, or like in pipelines such as like Axel and Ilfi presented. And then hopefully after now this week, or after years and years of training, we become like this highly specialized experts, right? And hopefully we'll master whatever data analysis we have to do. Okay, so now coming back to our pipeline, right? So that's kind of like guided us through like the week. So we started with data acquisition, some data inspection, processing, annotation, statistics, and validation, as well as hopefully data sharing and reanalysis, as Ming has nicely highlighted yesterday. And yeah, we presented you a couple of tools. And again, this is just like, you know, what we use, right? There's many other tools and many other like combinations of that, but typically it's kind of like a complex environment. So now that of course brings like the big challenge, you know, that it's like, it's hard to learn all of them. And especially when you start, you know, it might be overwhelming. So I think many fields and yeah, like many software engineers kind of like try to rather like collapse this and make things more simple and put this in like black boxes, right? As Axel like illustrated nicely. So now, similar for like molecular networking and this inspection thing, what we tried with the dashboard is kind of like have a very simplified version of this entire analysis suite and bring it only into one place, into the web browser, so you can do everything in the cloud and you don't have to download anything and manipulate anything. Of course, this is not as sophisticated as what we showed you over the week. That's why we actually showed you all of that, right? But like if you get started, or if you want to do like a very quick analysis, you might find like the dashboard also suitable. And especially working with others that are very new to that, you know, you might do not want to overwhelm them, but give them an easy start. So now, yeah, we showed you the full thing, right? Like feature-based molecular networking, which I think like is the probably most sophisticated way of analyzing non-targeted LC-MS data. But it also comes with the risk of like setting things wrong, and then things can go very downhill quickly, right? So there may be classic molecular networking out of the dashboard also might be a better start. But yeah, I think especially when it comes to like interacting with others, you know, like having not a complicated pipeline locally installed brings like quite some benefits. And that is on like this personal interaction level, like, I don't know, between you and your colleague, or you and the student you're supervising, or so. But then also within like the larger research group, right? Well, let's see how the outcome is, but like communicating our pipeline to all of you, that's challenging. Same within like the lab, and then particularly once we go to the community, reproducing things there, I think this is hard, and bringing everybody onto one page is also hard, because obviously there's many different ways and many different opinions. So now, yeah, what's the concept behind the dashboard? It's pretty simple. We just want to throw in an LCMSMS file as typically MZML file format. We want to throw it into the web browser and then get an XIC. And that was the first idea when Ming and I came up with it, to have this visualization just as a quick output of the molecular networking jobs we were working with. And yeah, since then, and once Ming got kind of like excited about it, things developed very quickly, and more functions came to the dashboard. And now you have like this, I don't know, like little kind of like analysis environment within the larger GNPS analysis environment. And yeah, like, so how we see it is that it's kind of like a central like place, hence dashboard, where we can like load in different data from different sources. So it's important to point out that there's multiple repositories from which we can directly pull the data. So again, making your data public, depositing it there, also helps you, because you don't need to like handle it on your computer or between computers. It's just in the cloud, and you just pull it at any time into like the dashboard. Then for like more sensitive things, you can also upload it from a local computer, and then it will be temporarily stored on the server, but it's not for long-term use. And then the whole thing does not only work with metabolomics data, but also with proteomics data, although with like very long nano LC gradients, the wait times might be a little bit longer. And then like you can also like directly visualize spectra and chromatograms out of like GNPS analysis tasks, which I found very convenient for checking and validating your results. And then you can also launch analysis from there. So it's not only a visualization tool, but also a quick way to actually generate data analysis jobs. And then very interestingly, you can interact with like your collaborators in multiple ways. So you can simply share URLs of your visualization and somebody can click on it. Or you can also do some sort of like real-time exploration where you can actually share an interactive link with like, I don't know, the students in your classroom. And then whatever you do in the dashboard, they will see kind of happening on their web browser in a kind of Google Doc style explorative way, which I think is also very nice. And then long-term, again, like the URLs, you can put this in not only, I don't know, in the chat to share with your friends and collaborators, but you can actually put it in the SI of a paper. And then, like the visualization and transparency of the final figures might be even like nicer, because I don't know, like people who read it can also, just by clicking on that URL, actually open the data that you put into that figure. All right, so where's the dashboard located? And here just a couple of words about GNPS. So we only showed you the feature-based molecular networking workflow, but the GNPS environment actually has a lot of different data analysis tools. And the more you dive into it, maybe the more like tools suitable for your personal needs you will find. But just to highlight a few, what we typically use is we take data, then we do like classical molecular networking, so that's without any feature finding, just looking at MS/MS, or do like the feature finding and then the feature-based molecular networking workflow. And from both, we can launch like mass analysis. That's what Ming showed you yesterday, where you query like a single spectrum against like the repository. So now the dashboard kind of like, again, like is a central spot. From there, you can like, pull data, you can launch feature-based molecular networking jobs. You can also launch classic molecular networking job and also like mass. So we really see it as a kind of like a central point to get started at. And then, yeah, like just a little bit background about the software infrastructure. So it's all open source. So if you want to deploy a own dashboard on your server, because you may work with like clinical data or so you can actually do that. Yeah, we have right now 24 cores, but I think as Ming is moving to Riverside, there might be like some changes in the hardware background. So far, yeah, we showed scalability in a couple of events with like 100+ users at the same time, and sometimes it gets a little bit slower, but you know it was still holding up, and there has been quite some people using it, and there have been quite some files so far visualized in the dashboard. Okay, and yeah, just to show you like very briefly like the main views, what you can get out of it. So as soon as you acquire like some mass spec data, convert it to MZML, and then upload it either directly in the dashboard or to Massive, and then pull it from Massive there, you can bring it in, and then typical things you want to inspect are like this LC-MS heat maps. So that is just like an overview of your data structure, right? And you have like here M over Z on the y-axis and retention time on the x-axis. And then, yeah, like with the heat map, the intensity of each of those peaks is indicated. And what you can see here nicely is that you also have like this blue crosses, which indicates the position of a particular MS-MS scan. Right? And here, well, we talked a little bit about like DDA and exclusion lists and like, yeah, like distribution of MS-MS throughout your analysis. I think this is a very nice way and a very intuitive way to like immediately see, okay, where was my MS-MS being placed? How was my coverage there, right? So if I would see only lines in there of like a few features, then I would say, okay, maybe there was something not that great. And like having this available to inspect public data quickly, that was actually one of the take-home messages for us, that a lot of people do not have that set properly. So then, yeah, like kind of like looking at this data frame from a different perspective. So we would now flip it by like 90 degrees. We can look at the total ion chromatogram. So there you have intensity on the y-axis and retention time on the x-axis. All the masses are summed together in this total ion current. So this is a few most analysis tools just provide by default. Then from there, we can like isolate mass traces. So in extracted ion chromatograms, you just like type in the mass you're interested in and a mass error, and will directly generate here extracted ion chromatograms for you. Here, the red crosses are now indicating MS-MS events for this particular mass trace, right? So here on this first peak, oh, we had like a nice MS-MS triggered at the apex. So here that worked well. For the second one, yeah, it was triggered a little early, and then not perfectly on the apex, but still okay. And like the coverage, okay, that was probably due to like the exclusion list setting that only lasted a couple of seconds. We get a couple of MS-MS events in between. And then, yeah, if I click on one of those axes, then I can get also visualization of the MS-MS spectrum, as you like see down below here. Okay, so then, yeah, like again, the visualization aspect is I think very I don't know, like nice and perhaps unique to it, as it's all in the web browser. You of course can like share this with like, I don't know, your collaborators, with your, you know, like people, lab mates in the lab, but also like with journal reviewers and the readers. And then, yeah, like there's the synchronous and asynchronous type of like visualization. So I can actually generate this like real-time links for a particular session and then share this with all of you. And then, you know, as we go through, you should see like the same stuff I do. For like long-term, obviously, you want to have the asynchronous. So this is just like the static view. Okay, so if you had a classic molecular network here, and later on, don't worry, we'll do quite some hands-on with it. A very straightforward way to get to it is just like click here on this cluster spectra link from like this network view. And then, yeah, with just a couple of clicks, you can open for this particular node here, the extracted ion chromatograms in like the web browser. And that is really important because, you know, like it gives you like so much more information than just like this reduced network view. So again, this was a classic molecular network. So we did not do any feature finding there, but only looked at the MS-MS. which comes with like a couple of caveats. And one of those is perfectly displayed in this XIC. So who of you has a problem with that there's 482 as a node, but there's like 2 peaks in here? So for like one XIC, right? Yeah.
Different RTs means it's doing something different on the column.
Exactly.
So
Exactly. So they're actually 2 molecules, right? Because they have 2 retention times and like they're very nicely separated. It's a perfect baseline separation here. And yeah, if we would inspect like the MSMS by clicking on those, we would see that they actually have the same MSMS spectrum. Hence, in the classical molecular networking, as this is all only doing clustering based on MSMS and no feature deconvolution, that has been simply collapsed into that one node, right? So now all these MSMS spectra are basically combined in this one node, and by default, you would think, okay, there's one molecule with 482, but no, there has been actually diastereomeres, which we could nicely separate by retention time. So here, perhaps with feature finding before, you would have gotten this as 2 nodes, but I think the nice take-home message from me there was for like classic molecular networking and quickly like inspecting it, the expert sees, oh yeah, there's more behind it. And that's how I think you should see any result of that, right? Always like before you write a story about now Yersinia Bactin in your paper, like look at like the raw data. And I think in like the following session, we want to kind of like do that a little bit and actually look at some of the raw data of the molecules that you I don't know, found interesting in the test data you used. Anyway, so now not only I can inspect this data, but I can also like do some quick analysis in here, right? So here now going from that one view to the other view, I actually loaded in some more files into the dashboard and I divided them in this USI1 and USI2 group. And now I can like simply ask the question, okay, how do those 2 groups like differentiate? So again, this is not like, I don't know, like big statistic times here, but like simple questions like, okay, is there a difference between A and B? You can do. And then, yeah, like you would see nicely, okay, in the top one, so the blue one, I see like this peaks. And then in the bottom one, the orange one, there's a flat baseline. So now we had a very simple question here because we knocked out a gene cluster and we wanted to ask, okay, is that molecule actually produced by that gene cluster? Okay, then NTMSS was knocked out, so then we don't see it. So, well, likely that was the case. I can go down and directly visualize this for you as a box plot, so you get kind of like an idea if the difference would be like a little bit more subtle. I guess here it was very clear. Okay, so yeah, again, this is our view. When you open the dashboard, you will see it kind of that, and then you'll see that there's a ton of other options you can click on. And one thing that is particularly useful for me, especially like working with people who do that like the first time, is that right in the dashboard, there's this little button that asks you, do you want to do feature finding? And then if you say, okay, yes, you can select MZMine and just do like a very like rough MZMine feature finding right there in the dashboard. Right now, it's still MZMine 2, so it's not the newest and most fancy thing, but to get started and to get like an idea of what you're looking at, it's quite useful. And one thing that I particularly like now is that like while developing this, Ming and I had like an ongoing discussion of how many variables we should actually define. And he at the beginning gave me 3 and I asked for 8, but then we negotiated a little bit and we ended up with 5. So now you only set like 5 settings, but those are the ones that we think are like most crucial for the feature finding, right? And particularly this MS1 noise level makes quite like a big difference. So now I can like set this, with what I think might be appropriate by actually looking at the spectra right in the dashboard. And then, yeah, I can like here either run this already in GNPS or on the other side, just like update the view. And then what you will see is that in that LCMS heat map, there will be now like these green boxes appearing, and each of them indicates a feature that was found, right? And now here I would say, okay, I have a nice coverage. If I would only have like, I don't know, 10 or 20 boxes, then maybe my threshold was a little bit too high. So again, this does not at all replace like standalone tools like such as MZMine3. They're way more sophisticated. For the expert user, I would strongly recommend you to use MZMine3. But to get started with a new person, that might be a nice first thing to do. So then, yeah, if you click here on this run feature finding at GNPS, you can then actually like load in more files and do this for like a full data set. So again, it brings you to like such a Prodeo safe workflow for which you could here select more input files, and it directly takes the setting that you pre-selected in the dashboard. Okay, then like navigating a little bit on the MSMS side. So again, here you see like this markers, right? They indicate an MSMS scan. And if you like click on one of those, then here in now instead of like the MS1, an MS2 spectrum should appear. And then you can like, yeah, interpret this and inspect it. But because we're already in the web browser, you can also directly ask, hey, what is actually that molecule? Please match this against the GNPS library. And it actually does it already without asking you. And you will see, oh, GNPS library, 3 putative hits, right? So maybe I'll click on that. And then you can like get to like a list and also like readjust cosine thresholds and so on. And then here in our case, it would like immediately show me that, yeah, this matched to like a spectrum from Yersinia Bactin. Okay, then in addition to like querying it against the library, there's also a masked spectrum in GNPS hit. So like what Ming showed you yesterday, going from like the molecular networking job, we can also directly launch out of the dashboard and hit masked spectrum. And then you should get like to this masked job submission that Ming showed you yesterday. Okay, and then, yeah, looking at some results here. Okay, this is now from Yersinia Bactin. So we see it's in a lot of like human microbiome related samples. Okay, so yeah, I hope I can convince you with that the dashboard may, you know, like facilitate a little bit like your day-to-day like data inspection during the research phase. I think it's really nice to use it for like the review phase, to like be transparent with the reviewers and also later on the readers, and put these URLs right into like the SI. And then, yeah, hopefully in the long run that, you know, allows people to, you know, kind of like check on your data, I don't know, verify your findings, and perhaps also, you know, reuse some of your data, because once you have it already in your web browser, you know, then you think, oh, maybe that's interesting for me too. Like, you know, let's click a little bit around and maybe launch some new analysis with it. All right, so yeah, again, it's accessible, so no software to be installed. You can use it right away. It's integrated with the community, so there's multiple repositories such as Metabolite, which Tom presented this week, is supported, Metabolomics Workbench, obviously GNPS and Massive, and then also like some proteomics repositories such as Pride. Yeah, we have. So, okay, with that, again, this was a huge effort, mainly done by Ming, because he programmed everything under the hood. And then also huge thanks are due to Peter Dorstein, who kind of allowed us to work on that a little bit as a postdoc side project when we were all locked down at home during the pandemic. And then, yeah, last but not least, everybody who was involved in like testing it and who gave suggestions during like the development phase. And yeah, they're all listed here as co-authors in the GNPS dashboard paper. All right, and now I guess most interesting for you, let's explore our data in the dashboard. I put 2 URLs here. Yeah, one brings you directly to the dashboard, and then the other one, which is perhaps even more important, brings you like to like the dataset explorer, from which we can actually like load in data like quite intuitively. And yeah, I'll go to the web browser here, and oops. So yeah, I opened the GNPS Explorer, and then what you see here at the top is that I can like specify a massive ID. So now, if you don't know what massive ID to open, I would suggest that you either go to our resources file and then open that initial massive link I shared with you. This data set. And then when you open it, there should be a big MSV number right at the top. So I can just copy this and then paste it here into the dataset explorer. And then you see it does something. So now what should happen is that I get like a long list with, I don't know, 51 pages here that actually lists all the MZML files that are available in that data set. So now I can make this list a little bit longer and then also filter in here. So if I type lab 15, then hopefully it should now only like indicate like the labs I'm interested in. And then, you know, I can just check mark here which files I want to visualize in the dashboard. So I would say for me, most interesting will be the comparison between M and A45A. So what I will do now is in that first group here, I will only select the M samples. So this would be here peak, not CCMS peak. And then I select the M samples. And then when you scroll farther down, you see already this comparison file selection list. So that is the way how you split it in this like two groups. So here I will now go down to peak. Oh, I also have to filter here. Lab 15, and then, you know, from the peak folder, I will select A 45M. Okay, so now I have selected these three and these three. So I think that's 6 files. That's kind of like a reasonable number. And then all I need to do is like click here, visualize 6 files. And then it should now open the dashboard, and it's already pre-populated with like the USIs of these files. And the USIs are here like the strings inside of like that box here. So now if you know very well the file structure of the data set, you can also directly manipulate it here, right? And like now, I don't know if I want to look at like lab 4 instead, and I know that the only difference is the file name and folder name, I can like modify that. But to start with, I would suggest to like start here from the dataset explorer, so you don't make any like typos when you get it. All right, so now we can go down, and you see here there's a couple of like things happening. So it does like some download and then some drawing, and then hopefully after I don't know, not too long, we should start seeing XIC and TIC and the heat map. Yeah, dataset explorer. So it's this URL here. So and then I copied the number from our massive dataset, and this I got from the resources link, right? And then when you copy this number in this field up here, then like all the files that are present in this data set should appear in that list. Oh. Well, I hope we didn't kill the server at UC Riverside now. No, no. So you don't need any login.
The job, so we can open it to the discussion. I didn't cancel.
Yeah. So I just reloaded it, and then. Okay. All right. So who's seeing this now? Okay. Because Ming is still sleeping, I couldn't even text him to fix it. So then, just like maybe to start, let's just start with one file. You can filter here whatever lab you have, right? So for me, I don't know, let's start with lab 5. So, and then you can select here by clicking one of the boxes, like a file you would be interested in, and then hit visualize one file. No. So it should happen right in there. So now, because I mean, because a lot of people are like hitting it in parallel, it might take a little bit longer than usual. So normally it should just take like a couple of seconds to reload it. So then, yeah, like once it's loaded, there will be ready signs here, and here you can see, okay, it now established already like that heat map I talked about. And then when I go farther down, I see again here like the TIC. So yeah, that would be basically like the same information as this one. And now I can see already very nicely, right? There's like kind of like this island here in the middle, and there's like nicely a lot of like MSMS placed on it. And I have overall, I would say like a pretty good distribution of MSMS coverage, both over retention time and mass range, right? So that's, I would say whoever lab 1 was I think Allegra. I think that they did a good job with like setting this up. At the bottom, I can also see a little bit information about this. Besides like the file name of the USI that is visualized, I can see the total number of scans and then the distribution between MS1 and MS2. So now, yeah, I think for Q-exactive, this is in a 10-minute gradient, that's kind of like what we would expect. If this would be now like an IDEX or I don't know, like a HF, then you would expect more MS2s to be triggered. But yeah, really important is like how they're distributed too, right? If they're all triggered on the same mass, you're not gonna find much. And then, yeah, so like now let's actually explore this a little and let's verify some of the compounds that we found. So who can tell me M/Z value of one of the molecules that you would be interested in? From your analysis so far. Wait, how about 3 or 4.1 something? I don't remember the. What is it? 1, 2.
First thing is on my screen in the series.
Okay.
It has a structure.
So now, yeah, for generating this XIC, I simply type in here the mass, and then I can toggle between tolerance unit of Dalton. So that would be absolute or ppm as relative, and then yeah, default would be here either 10 ppm or 0.5 m/z. And then if I go down now, here on the right, it should start generating an XIC for this particular mass. And yeah, again, it takes a little longer today. Normally, this should be much faster. But let's give it a second and hope that something will appear. Okay, so now I got an XIC here. And how does that look to you? Yeah, that looks like spiky slash noisy. So that does not look like a great peak. We have 200,000 abundance. So yeah, it's like not like too little. So I would expect that maybe was that mass correct here? Okay. So actually, let's quickly recalculate this. Very important, if I calculate exact masses here with this exact mass calculator, that is for like the neutral molecule, right? So I would need to subtract the electron mass too. For now, I'm just gonna use like a little lower tolerance and then it's fine. But if you want to do it like very precisely, don't forget about the electron. Okay, and then I go back to the dashboard. And then now hopefully, as I update this with the correct mass now, oh, I see a very nice peak. So at least from the chromatography side, that makes me happy, because that I would say is a pretty good peak shape. now from the MS placement side, you know, it's not perfect, it's not at the apex, but you know, in a complex sample with thousands of compounds, we can't be like too picky about being everything being placed at the top. But yeah, so like now just from yeah, I would say, okay, there is a molecule that has like this mass within 10 ppm tolerance. We have a nice defined peak. We have 2 MS. So eventually what I'm gonna do now is I wanna click here on like this marker to like inspect the MS, and maybe because I've seen that spectrum, I would say, okay, I believe that this is something. But then again, I can also just like directly click here on this GNPS library hits. And then I should now below here get soon like a list of like molecules or like library like entries that this spectra matched to. Above here, if I don't find anything and I want to lower the tolerances a little bit, I could like set a lower threshold, you know, and then try again. I could also allow analog matches. So that would be other spectra that have different precursor masses, but share like the fragmentation patterns, you know, to expand a little bit my search. But for us now here, I got a lot of hits. I got very good cosine scores, right? 1. So that means that's a perfect match. And then, okay, there is a spectral match to benzoylgonine, but then with a delta of 14, right? Remember that was already something we had related to it. Then there is a D3 cocaine, but also with the delta of 3. So it all points to like actually cocaine, right? And then again, they all have the same match and they're like just like listed as possible hits. So now, yeah, I would say, okay, it's probably very likely cocaine. But now I could ask, okay, where else is this found? So to contextualize, and I mean, here, obviously we I guess know if that would be an environmental sample, it might come from like, you know, like some sewer pollution or so. But if it's like an unknown molecule and I have no idea, then, you know, like contextualizing it and asking, hey, where else in other data set is this found? Maybe, you know, I can like get a hint about like the use or origin of it. So I click here on masked spectrum. And then now for masking it, I actually need to be logged into GNPS. Otherwise it won't do it. So I'm gonna log in here with my user account. And then probably have to click it again. And now, yeah, it should pre-populate this Proteus safe workflow, right? And then I can just say cocaine masked. And I eventually want to adjust here the mask accuracy to something more high resolution. And then submit. And then, yeah, if you do that in 15 minutes or so, you should perhaps get a result. Till then, we can like try a couple of other things. Maybe as the performance was already slow, let's not all run feature finding at the same time, as this is also computationally a little expensive, but I'm just going to show it to you really quickly here. So I really would just like scroll up and say here under LCMS fewer options that it should actually do here feature finding. And then also, you know, I can like set like different like tools in here. So if you want to play around with MassQL, what Ming showed at the end yesterday, you could also activate this here and put in MassQL queries. But yeah, for me now, I want to use MZMine and then select this. And what should happen now is that like this new box should appear where I can set like the thresholds. And yeah, I would say 10,000, that is probably a little high. Maybe let's start 100,000 and then, you know, the rest, let's allow wider peaks and maybe lower the mass tolerance a little, because that has been pretty good chromatographic data so far. And then, yeah, once I set this, I just hit here, update feature finding interactively. And now it should actually start rerunning the feature finding for this one file. And then hopefully once this is done here, now in that map, like this green boxes should appear, and we would see what features have been found. Okay. I'll let it run now for a couple of seconds more. In the meantime, do you have any questions so far about the dashboard? Yes. So when you go up and there's this button, upload files, you could also upload a file right away from your computer. It, I think, even does raw file conversion for you. So you could technically upload directly your thermal raw files, but I would suggest to do that with MGML because it's just smaller and it's more efficient. If you do that, if you upload it from your local computer, it won't be there permanently. So then you can't generate these URLs and share them long time with others. So therefore, it really needs to be in a public repository. Also, right now, it does not support private data sets. So that's still something we have to fully implement so that you have a data set in massive and it's private. So it's only accessible with a password. Then yeah, like the idea would be to also support that, but right now that's not working. Yes. So that's actually like a new thing for Massive, that the user accounts have only 100 gigabytes of long-term storage. Before it was unlimited, but I think because people kept a lot of files in their private space, that's not what it's meant for, right? So they recently put like a long-term limit there. That does not apply for public data sets. So if you upload whatever data set, you can do that and then make it just public, and then there's no limit. Obviously, that should be within reason, right? So don't upload duplicated files or things that nobody needs. But yeah.
So for now, this seems to be all for LC or GCMS.
Mm-hmm.
I know there's a good reason for that, but you think they will do something?
Yeah, so for Massive, you can upload any MZML or any XML file. So this can be direct infusion stuff. This can be single scans from, I don't know, like average top-down spectra whatsoever. I would assume that as soon as this is MZML file format, you can also visualize it here. So if you do flow injection analysis and you have, I don't know, 10-second acquisitions, it will just display it as a chromatogram, right? But obviously it's not a chromatogram. It's just like the summed or like the scans over the infusion time. So that should work here. Okay. Any more questions?
On the top, you have the GNPS IT. Can you explain on the plan?
Where's that?
Like on this dashboard in the top.
Yeah.
You have like 3 rows.
Yeah.
Explain what's the difference again?
So this was like this comparison groups, right? So I have USI1. So this is something I can display here on the left. And then if I would load in a file in USI2, I could display them in a different window. I can show you in a second. And that is, yeah, a simple way of structuring your data in here if you want to compare A to B. If you only want to visualize one file, you know, just use that. I could now, by manipulating these URLs, you know, load in more files, and then with that middle selection thing, I could actually jump between them and visualize, because it only visualized maximum 2 at a time, right? But then if I'm gonna do it at the end, if I have like multiple, you know, divided in that group, I can make use of like the integration and directly show peak area in the box files. But for now, unless there's more questions, let's check out the feature finding results. So here I can see now nicely, oh, there's a couple of green boxes, right? And because it's not so great to see with the all MS things, you know, I can simply here uncheck this show MS2 markers. And then it's also gonna take a little bit now, but yeah, now it should remove it and only showcase the features that have been found over that heat map. Okay, who thinks that this is a good result? You, okay. Yeah, so there's a lot of features, right? Who thinks that this is a bad result? Okay, or who thinks it's not an ideal result? So here, these are like the different features placed, right? Or the different features that were recognized throughout like my map. No. This is for all. This found now all features, right? Yeah, so there is a lot missing, right? This entire range here where we had a lot of MS2s placed, right? Which was really nice. There is no features found. So I would say, I mean, it's kind of okay, but it's not really deep, right? So there, most likely I selected a too high threshold. And that, I don't know, I don't know who adjusted their thresholds on the exercise on Tuesday, but that is really like a critical value. You know, if you don't set that like appropriate, then you either find like, I don't know, tens of thousands of features or I don't know, very, very few. So here, what I would do is I would just like lower this now to maybe 100,000 and then hit update feature finding interactively. And then hopefully it does not take like too long to like now, you know, rerun that and then display it. So if I looked like at the first time for like some data from somebody and I just say, hey, I make it public, then I load it in the dashboard. We do like a quick check here, and then I roughly know already, okay, where should I put the threshold? Obviously, I can also derive this by, you know, like looking actually at the data. So if I click here at any time point, you know, technically, unless it's busy with the feature finding, you know, it should display here like the MS1 scan. And then, you know, by zooming in some of these areas and figuring out what might be noise, you know, I can like come up with like, you know, a threshold. So here I would say, okay, well, DOM is really complex, right? I have a ton of peaks at every nominal mass unit. But I probably would select something like around like 100,000. Okay, and then if I did that, you see it just updated here on the left. Now I have like this super big coverage about like all like these features. Right? So, and now again, let me quickly turn on the MS2 markers. Let's see. Okay, so there's very few MS scans that are lone standing, right? And that to me is a good indicator, because if something triggered already in MS2, then that is kind of like a good sign for me that that might be like a real signal and not noise, right? So there, you know, like I kind of look at like the both things at the same time. So now, you know, maybe you say, okay, that could be something like appropriate. So now you could use those as a threshold for your data analysis in MZ-MINE3, because that initial, you know, like noise thresholds are kind of like critical. Mass tolerance and like retention time tolerance, we kind of know already from our like instrument and like chromatography performance, right? So there you don't change too much. Okay, with like this boundaries, you may change things, but like that threshold that's really like critical. Or if I don't want to, you know, go now to my own computer, I can just say run feature finding at GNPS with these parameters. Yeah, it still has a disclaimer that it's better, but I think it works most of the time. So again, here I would need to sign in. Yeah, an important difference, this is proteomics 2, so this is our beta server. But yeah, you can use your standard GNPS account to log in. You know, and then it should bring you eventually to this MZ-MINE workflow. And now, yeah, again, this is MZ-MINE 2.53, so like it's old news, you know, but you know, to get started, it might be useful. And now, in addition to that initial file we had, I could now here open the selection input file tab. And if I had that data in my user account, or if I pull it from Massive, you know, I can directly add more files into it. And that might be another trick. I don't know if we showed this to you, because we only use the quick start for the submission. But there's an easy way bringing in public data also into your own workspace here to launch it. And that is by like here using this share files tab. So you can see now I don't have any DOM data here, right? So there's only my own user data that includes, oh, actually I uploaded lab 15. So if you uploaded your data to Massive already with the FTP, what we showed on Tuesday, then that might appear here. If not, no problem at all, because I can just go to this share files tab here and now use the same Massive number. Hopefully I still have somewhere. Oh, yeah. I just use this number here, copy it, and then import data share, paste this in, and then hit import. And now when I go back to my select input files, you know, this should be now listed here as a public data set that I have accessible in my user folder. And now I just expand here the file tree, go to the peak folder, then find my lab. What lab did we use here? 1, right? Okay, so then I just can expand here lab 1, and then, you know, I can either select all of them individually or I select the entire folder, and then I put this here into spectrum file G1. Now I have to be careful because I selected already one file of them before, right? So I want to remove that again. So I just click on that so it's highlighted, and then click here like this remove spectrum file button. And now I only have like all the MZML files from lab 1 selected. I hit finish selection, and then okay, I have to go back here, and then, you know, I give it a meaningful title, lab 1 workshop test. Also, I really like adding a date, so in a couple of years I hopefully remember more easily, you know. And then yeah, this is 253. And then, yeah, so the settings, I can double check here under this advanced MZMine2 parameters, but those should be exactly the ones that I set in the dashboard before. And then I just say go. And now in also 15 minutes or so, I will hopefully get an email saying that this was finished. And then I can either download the CSV and MGF file onto my computer and proceed in a similar fashion as you did, or because it's already online, I just click one button and say, okay, and now run the feature-based molecular network from it, and then we can move on there. So really, it's kind of like happening all in the browser, and there's no software to download. Again, that's kind of like a very, I don't know, light version. So there's a lot of things you can't do here. But I think to get started, it might be a nice way. Okay, going back to the dashboard. Okay, now we did the feature finding and everything, but maybe you were not interested in that, and you just wanted to, you know, showcase the results of, you know, cocaine, because that was now the most important feature you found, and you want to convince, I don't know, somebody to be a drug addict, and now you want to, I don't know, put this in a report, so you can, like, you know, visualize the XIC. Wait, this is now a different mouse, right? So let's, yeah, visualize again like this XIC. And then once I have that visualization that I like, you know, oh. So it's still zoomed in at the other. Sorry, it said already like the integration limits. But now, yeah, okay, we're back in our view. So, and then I want to also display the MSMS, you know, as like, well, as like the characteristic for this compound. So now I can like, you know, make a screenshot of it, and that would not give me a vector graphic. So that might not be what I want to do. So I could also go here, you know, to just say rendering options, select SVG, you know, and then click here like the download plot button, and then directly download the XIC plot as an SVG. Then I could download the MS2 plot as an SVG and like, you know, visualize it downstream. And then very importantly, I click here on copy URL link to this visualization. Now, this is a very long link, but, you know, in the SI, I might not be limited. So let me. Okay, I don't remember my password. Okay, anyway, so I get like this long string, you know, and I can just like paste it in whatever document, right? If that would be the editor here, I paste it here, you know, and then like that could be now the SI, and I, you know, organize this in a table and say here, I don't know, dashboard link, lab 1. So in that way, everybody can like reproduce what I did. Then now the SVG here, you know, I can, I don't know, is there Inkscape already installed? If I had Inkscape installed, you know, I can directly open it and then, you know, combine it with whatever other elements to like a figure. All right, I think that was pretty much what I wanted to show you. So now, you know, as we move on, I would suggest that you actually like play a little bit around with it and then try to export some, yeah, like views, both on like the, you know, MS1 or MS2 level, and then yeah, add those into your vector graphic program. Yeah, for those, okay, PowerPoint actually, we should have, right? So at least that we can all use, and then, you know, you can drag and drop it in here and then prepare it for your presentation later. Or again, let's see, group, ungroup, you know, I can like disentangle like the different elements in here, and then like Allegra did, you know, remove certain things that are not meaningful, whatever, you know, and shape this into a way I want to display it.